All right, thanks everyone for joining. We're going to go ahead and get started. So this is the welcome to the session on the Agile Nirvana of DevSecOps and Containerization. So here's what you can expect in the next probably 45 minutes. I'll probably go all the way through. There's a lot to cover. Security is near and dear to me. I actually come from the security background, so I can talk a lot about it. And it's really, I think, my goal with this session, if you guys walk away learning just at least one thing and tweak the way you do things to tighten up security just a tiny bit, I think we're going to make a big difference in the Sitecore space. So we'll start off with the foundation around DevSecOps. We'll talk about what it is, what it entails, what it really is, what security entails, what the scope of security is within the Sitecore space. Talk about how containerization now makes DevSecOps cheaper for us. And then we'll take a look at a couple of cloud options. We'll compare which one's better for hosting Sitecore. And then we'll cover some of the most important things that you can take away from here to get immediately started on, the DevSecOps journey with Sitecore implementations. So, quick intro. My name is Vasiliy Fomichev. I'm a Senior Director of Solution Architecture at Altudo. I've been working with Sitecore for over 14 years now across all products. I've been a Sitecore MVP for the past 8 years across all categories, technology, commerce, and ambassador. Been running Sitecore practices for the past 8 years, and really I'm at heart a MarTech enthusiast. Been spending quite a bit of time in content, playing around in Azure with AI and blockchain. So if you guys have any questions around what you will see in this presentation, feel free to email me directly using my Altudo email, or find me on Twitter or LinkedIn. I'm on social, or Slack, or fill out any of the contact forms on altudo.co or my blog, cmsbestpractices.com. I represent Altudo, and we are a Platinum Sitecore partner. We're a leading Sitecore partner for the past 15 years. We're fully badged across all Sitecore specializations, and this year alone, we're honored to have 8 MVPs on staff with us, 6 technology, strategy, and ambassador. All right, so let's get into the fundamentals behind the DevSecOps. So what is DevSecOps? Well, we know what DevOps is, right? So development and operations. We develop the application when then we operationalize the deployment, the release, and everything around the story. DevSecOps is development, security, and operations. Sounds pretty straightforward. So why is this important? Well, first off, I think all Sitecore clients are going to be a lot better if we start taking security a lot more seriously. And I think if we all walk away with, again, having learned some things and maybe even talk to at least 1 or 2 people about the things you're going to see here today, I think we could set something else in motion that's going to actually help propel Sitecore on their path to composable architecture. Okay? Another reason why it's important is this graph right here, the hype cycle. So this is a Gartner's hype cycle for Agile and DevOps. It consists of 5 sections. The first one, this is where the technology just starts off. It gets invented, innovators jump on it, innovators start applying it in various ways, they get excited about it, they try messing around with it in various ways, and then it gets into the second stage, the peak of inflated expectations. That's where it seems like technology is just going to solve all the world problems, right? You start hearing about it at conferences, Sitecore Symposium, everyone gets excited about it, it's going to cure cancer, and then when you start using it, you realize it actually won't, and then so the technology starts declining, dropping in interest, and then it gets into what Gartner calls trough of disillusionment. Some technologies die here. Some survive, those that are solid, right? What you'll notice is DevSecOps survived the stage and it got into the scope of enlightenment. This is where technologies start finding their real, true applications and start getting adopted at scale. So Gartner rated DevSecOps as a top transformational technology last year's report, so last year in July, so we're about a year out, saying that this is the top transformational technology that's going to hit our space in about 2 to 5 years, which is 1 to 4 years now. Okay? So DevSecOps is about to hit massive adoption. So it's not only important to be aware of what it is, it's important to know how to do it, right? It's simply for job security. So what is DevSecOps? Well, it is a methodology that puts security into every single step of CI and CD. Okay? How does that differ from the traditional way? Well, this is the picture we're all used to seeing. Traditional way of building, testing, deploying, monitoring, learning, and so on, right? Traditionally, what we've been doing is putting a gate somewhere towards the end of the testing stage to validate for security flaws, right? Some companies went even further, introduced other gates at other steps in the cycle. Let's say after releasing the software, you would do some pen testing. But the problem with this approach is, one, during the whole cycle, you haven't really been thinking about security. And then you got to pass the security test, right? So a lot of things got sent back to developers because that security never got accounted for. So that started creating dramatic delays in DevOps cycles. It also started creating friction between the CISO and developers. So developers thought that security folks were too picky and just messing with them, and security folks thought that developers had no freaking clue what they were doing, right? So that continued, and all it did is just kept increasing the cost of DevOps, right? So the solution to that was DevSecOps, and DevSecOps literally fuses security into every single step of the operations, right? So how do we do that? How do we integrate security into literally every single step of DevOps? Well, DevSecOps is founded on 3 layers. First one is education and knowledge retention. First of all, this is what we're doing now. We have to educate ourselves about what DevSecOps is and what security is. And then we got to come up with a system that's going to allow us to retain the knowledge that our coworkers have within the organization. Statistically speaking, in technology, 1 out of 5 or 7 your coworkers is going to leave this year. So you get back to work, look at your coworkers, and think how you can pull the information out of their head into a knowledge base that can be retained within the organization. Okay? So once you've educated your audience, you start designing based on that knowledge. And design doesn't only touch the design of the software. It touches design of the team, design of the process, design of the workflow. Only then you get into the software itself. And finally, only then you get into the automation. This is the biggest, I think, flaw in the definition of DevSecOps that I've run into is a lot of people think of DevSecOps as just simply automating security testing. But it's not. If you don't have the foundational pieces behind that, all you're doing is just you're automating the bad stuff. You're automating the pain, really, right? So it's important to educate yourself, design, and then automate. But you also have to do it to a point. Security is expensive. It's incredibly expensive because it's incredibly complex. And it's a cost-benefit exercise. When you start thinking about integrating security into your DevSecOps processes, keep that in mind. You don't want to get into the trap of being a security astronaut, where you're just simply doing things by the book because the more the better. It's not. In reality, what should happen is the security office should list all the flaws and all the risks that exist, for instance, in the environment. There should be a dollar amount put next to each risk, and then the business needs to decide whether they want to mitigate or accept that. So there will be certain things that will need to be mitigated, baked into the pipeline. Certain things will just, the business is okay to live with, right? So that's an important piece to keep in mind. So there's a lot that can be done in DevSecOps. There's a lot. Probably a lot. You probably won't even get to 80% of that. But that's because of the expense that comes with it. So what is security? And how do we infuse security into the DevOps process? Well, security is founded on 3 also pillars, so to say, with the abbreviation of CIA. C stands for confidentiality. So this is where we have to make sure that the right people have access to the right systems, and the right systems have access to the other right systems, and people and systems have access to the right data, the right access to the data, right? I stands for integrity. This is where we've got to make sure that systems stay in the state we want them to stay in. Data stays in the state that we want it to stay in, and we don't have any suspicious behavior. Finally, A, availability. And this is the one that gets overlooked a lot. And this is interesting too. So availability means we have to make our systems and our data available when it's needed. This is interesting because it also deals with performance. So now all of a sudden we're starting to put things like stress testing, load testing, longevity testing into the bucket of security. And so keep that in mind. So how do containers make DevSecOps cheaper? So this is what we're here to talk about, right? So one thing to remember is containers is really another type of virtualization, right? We know it's not going to solve cancer. A lot of the things that you can do with VMs you can do with containers and vice versa. The biggest difference is containers are lightweight. And immutable, and all the benefits really stem from that. So it's a lot cheaper to create and delete containers. And what that allows us to do is to get rid of the infection, if we had it, with our next deployment. See, with VMs get nurtured. VMs get created, and then they get nurtured by the infrastructure team, by the developers, by the DevOps team, upgraded, updated, and grown, where containers are short-living entities. So if a VM gets infected, you'll be lucky to find that in a few months, if ever. If a container gets infected, you'll get rid of that infection on the next deployment. Containers are immutable, right? So, and immutable environments create consistency, predictability, and stability. And that goes for the availability of the CIA principles behind security. We don't have to remote into our containers. This is what we have to keep in mind. There's no need to ever remote into a container. If you want to troubleshoot, instantiate a container out of the same image on your local environment. If you need to make changes to the container, make the change to the image and redeploy the image. So what that allows us to do is block all types of remote access into the container. Just shut it down. And that reduces the attack surface. And finally, cost efficiency of operations. If you're doing things right, you're automating a lot of the maintenance, updating, patching with infrastructure as configuration, and we'll take a look at that. Infrastructure as code, we'll take a look at that on the upcoming slides. But there's about a 10 to 15% decrease that you're going to realize in your maintenance and operations if you're doing things right. Okay? So there's a lot more that you can probably find online around why containers are good for DevSecOps. But keep in mind that everything that you can do with containers, you can also do with VMs. VMs are just a lot heavier. You can script your maintenance. You can script updates. You can recreate VMs and so forth. They're just a lot heavier, so therefore it's impractical. That's why we don't do it. It's not that it's impossible. So now that we know how containers can help us, where do we go to host them when we try to set up our DevSecOps instance? Where do we create our pipeline? Okay? So on the cloud, we have three options. These are our traditional options with Azure, AWS, and Google Cloud. Right from the start, I want to cancel out the Google Cloud. It's not going to work out for any of the enterprise. There's a lot written about their deprecation policy. Google Cloud deprecates their APIs every 2 to 3 years, and when they deprecate things, they really mean it. They don't support the legacy implementation. So if you didn't update your application to work with the new version, your app will go down. And with enterprise projects lasting years sometimes, that's just not, it's a non-starter. Even for smaller projects, I wouldn't recommend starting with that because there's an extreme shortage of skill set for Google Cloud specialists. It's going to be extremely expensive for you to find someone who really knows how to work containers in Google Cloud. So what we're left with is Azure and AWS. So what our team did is we went through a checklist, created a checklist of 84 points comparing Azure and AWS. And we scored each one, both cloud platforms, on the scale from 1 to 5. So 420 points total. So here's where we ended up. Azure gets 350 out of 420. Here's some highlights. Azure, which is the AKS on containers, is fully supported by Sitecore. Okay? Because of that, Sitecore community aligned right behind it. And these 2 points have a lot of weight here. More weight than just 1 to 5 scale. So that's why they're being called out specifically. There's a lot that comes with it. Community support, troubleshooting support, all the goodies that come with community support and the technology being popular. Right? Lower cost of hosting, surprisingly, is with Azure. And we'll talk about that on the next slide, why. Then we have burst options, which are only available in Azure. One of the things problems you're gonna run into with containers is scaling your nodes quickly. So if your client or if your organization is subject to flash spike traffic, this is gonna be a game changer. Azure is capable of burst scaling, what they call it, nodes where normally, traditionally, takes, what, about 15 minutes or so to provision a VM. So Azure has an approach for fixing that. Easier to get started, just like with any Microsoft product. Fully managed control plane reduces cost of maintenance. Image signing is important from a security perspective. This is something we don't think about frequently, but we do have to make sure that the image that we're pushing into Kubernetes is the same image that arrives at Kubernetes. So signing with Azure allows us to ensure that, to avoid the man-in-the-middle attacks. Integrated resource monitoring comes out of the box. And Azure provides specifically tuned options for government and healthcare, so it's more attractive to those clients. Let's take a look at AWS. 363, not surprising. AWS is the most widely used Kubernetes service out there. And a lot comes with that. There's a lot written about it, a lot of support, a lot of help around EKS. 99.95% SLA, which is also achievable with Azure. You just have to configure it, but as we know, default configuration matters a lot. Just remember the Mongo ordeal where everybody accepted the default admin password? Same thing. Image security scanning is provided with WS out of the box. But this is where the good path starts getting shaken up. So this is where we get into the negative. Lack of automated node repair support as compared to Azure. If your node goes down on Azure, Azure is going to recreate it, restore it. AWS won't. It's going to require additional support here. Additional charges per hour per cluster, so 10 cents. This is where that extra cost for AWS comes from. That's why Azure is actually cheaper. So ideally, you want to create multiple clusters for environments. And once you start getting into the multi-cluster setups, that cost starts adding up pretty quickly. Liability concerns around limited support for AKS by Sitecore. This is perhaps one of the most important points on the list. See, Sitecore supports Kubernetes in the technology. Sitecore supports Docker. Sitecore supports AKS. Sitecore does not support specific configurations that are specific, the configurations of Kubernetes that are specific for EKS. So if you have a problem in EKS, you file a support ticket, they'll do their best. They'll try to recreate it, but they'll try to recreate it in AKS. They can't recreate the problem. They will still try to do their best. There is a best effort clause in Sitecore support. But do you want your clients relying on luck? Right? Do you want your clients relying on the chance that the support person knows EKS? That's one of the biggest things here. Harder to get started with as compared to Azure. Requires a third-party monitoring system. And as a result, the recommendation was to go with Azure. Now, this was an interesting case study. I'm not going to disclose the name of the client, but the client is a huge healthcare client. And in fact, all of their infrastructure was in AWS. And after we've gone through this evaluation, even though their whole enterprise, and they're global, mind you, their whole enterprise was on AWS, their compliance department made an exception to host Sitecore on Azure specifically. And the reason for that is, again, support for AKS, community support, more advanced security features on Azure. Because it's a healthcare client, obviously, benefits for that. Lower cost of hosting and lower cost of implementation and maintenance by about 25%. So that's significant. So next time you're thinking about implementing DevSecOps for Sitecore, keep these points in mind. So, how do we actually get started with DevSecOps and Sitecore? Well, for that one, let's go back to the 3 foundational layers of DevSecOps. So first of all, remember the first layer was education. So here's the things that we can do to educate ourselves and our teams. Plenty of ideas. Plenty of ideas. From self-paced instructor-led classes to tutorials. Gamification is a fun one, like hackathon. Trying to create or hack systems. Pair programming, lunch and learns is something that we do at Altuda. This is where, let's say we have a call every couple of weeks where we share the new learnings around technology, around the things that we see our clients asking for instance. Informal knowledge sharing, similar. Experimentation is interesting. If you ever worked with Sitecore marketing tools, you might know about experimentation as split testing. Right? Marketing folks would test which version of the component results in a higher conversion rate. Well, we can actually do the same in technology. There, as you'll see on the upcoming slides, there are many tools that we can use in our DevSecOps pipelines. And every tool is different. Even though a lot of them offer code quality checks, static scans, dynamic scans, a lot of them seemingly offer same functionality. They're still different. So the fact that one team is successful using this application for security scanning doesn't mean that your team is going to be successful with that same tool. So experiment, try new tools, play around with them, sign up for free trials. Gosh, they have limited functionality, free trials available for a lot of tools. For SonarQube, for instance, sign up, test it out, see how it works. Does it work better than the one that you're currently using? Continue improving. Try out a new process. Try adding a step, removing a step. Continue optimizing. Right, that's the point. Learn from incidents. That one seems straightforward, but very few do that. When things go wrong, people don't like going back and digging through it, right? It's something that we have to do. And then certification. Certification is an obvious one. ISACA, CompTIA, ISC2. I think they all offer security certifications that you want to get your teams on. Once we've educated yourself, let's start designing things correctly, right? So first of all, we're going to make sure that the right people are put in the right roles. Teams are structured correctly. The system design accounts for security. Our processes, our workflows, everything starting from development all the way to the CI/CD pipeline, the gates, everything has been put together with security in mind, and we'll touch on that more. Make sure you bake in OWASP and MITRE 25 best practices into your flows. Peer code reuse, threat modeling. Try to play the hackathon game. Try to investigate how much damage can be done if you leave a certain thing open, for instance. And of course, use the OWASP security knowledge framework, and only then get into the automation. And there's a lot that we can automate here. There's a lot. Starting from basic unit testing, which we don't actually think of unit testing as something that can help us with security, but it's in fact the cheapest way for us to provide the highest coverage for our implementation for security purposes. So we're going to touch on all these tests here in the upcoming slides. I'm not going to talk about it here. So let's dig into each one of them. Education. If you have a cell phone right now, take a picture of these QR codes. The first QR code will take you to the Docker CIS Center for Internet Security benchmark. This is a checklist for security items that you want to make sure to do whenever you're working with Docker, and same thing for Kubernetes, security checklist. But here are the top ones that you want to keep in mind. One of the, probably the most common problem is that we keep our secrets in our images. Now, inject them. Don't keep them in your base images. Don't keep them in your source code. Inject them from a secure source, like Key Vault, for instance, in Azure. This is the source of most security issues, let's say with containers, based on statistics. The second most common problem is elevated access for the user running containerization service. An attacker can escape the container, use the elevated privileges to gain access to the host machine. So make sure that the user that's actually running the service doesn't have admin privileges on your VM. That's one of the basic ones, but frequently overlooked. Disable all remote access, just like what we talked about. There's no reason to get into your containers, ever, ever. Use namespaces to limit access. Use the namespace at least per every environment. So whatever it is, development, QA, UAT, SVT, testing, whatever you end up calling it, all environments should ideally have their own namespace. Right? There are some cost savings associated with sharing a namespace, for instance. For security purposes, it's best to keep them separate. Enable image signing to avoid the man-in-the-middle attack. Right? This becomes especially interesting if you're in a highly regulated industry, especially if for instance, images are stored in a totally different cloud, different location, or on-premise, and you're talking to the cloud. So your images have to go across the wire, to get into Kubernetes. This is going to become very important. So man-in-the-middle attack can be prevented with Azure Signature Signing Content Trust. Use tagging and semantic versioning. So Rob Earlham actually has a great video on how to tag images, how to properly tag them, use semantic versioning. Avoid labeling your images with words as much as you can. This is one of those security by obscurity, common sense principles. However, just, you keep seeing latest, stable, once in a while. This is a bad practice from a security perspective. If I'm a hacker and I somehow got access to your repository, I know exactly what to look at, what image to mess with. Do not rely on external image sources. We have our Sitecore repository for images. Fortunately, some companies rely on that repository for their base images. You want to remove dependency on third parties as much as possible to begin with. That's one of the common sense security principles. Set up your own repository. Bring the images in that you're interested in, that you're using, and use that as your base image repository. Please do not use Sitecore repository. Because one, it can go down, and you're out of luck. Two, you can't stop man in the middle attack here. So what you think you're pulling may not be what you're receiving. Scan base images for vulnerability, about 24 hours or so. In fact, you can scan images at 3 levels, and I think we'll touch on that on the upcoming slides. Scan them at the IDE level, so a developer should be able to scan their images. Scan your images at build time, and also scan your images for vulnerabilities every 24 hours within your repository. And finally, use hardened VM images. If you're hosting on-prem containers, first of all, you're brave. Second, use hardened images from CIS. CIS provides hardened Windows images that you can use on your VMs. They're already tuned to be hardened out of the box. You don't really have to mess a whole lot with them. Also on Azure, I do believe you can also load your own custom images into the VMs on AKS. Okay? So if we follow these principles alone, we're going to eliminate at least 80% of issues we can potentially have on the security side of things. Okay? So now let's talk about designing. And the first thing when you think about designing, you got to think about putting the right people in the right roles, in the right teams. So traditionally, we have our development team. Right? We have developers writing code, QA testing it, DevOps engineers creating pipelines and making sure stuff goes out correctly. And then on the other side, we have team security. We have a security information officer creating the program, and then we have a series of specialized security staff. So how do we bridge this gap here? How do we ensure that these guys are aware of all the things that security requires when they perform their daily tasks? We can't scale our security personnel. Security is expensive. Statistically, there's about 1 security professional per 400 developers. Think about it. 1 security professional per 400 developers. When I learned about that, I thought I was in the wrong space. To add to that, security specialists also specialize in different things. It's like developers, right? We specialize in .NET, we specialize in Sitecore. You can't put a .NET developer work on Java, right? It's going to be a learning curve. Same thing, security specialists. They have specializations within the so-called security space, right? So the ratio is actually a lot higher than that when we talk about web projects. So obviously we can't staff our security side. So that's why a lot of that just gets outsourced. But what we do need to create is the champion team. It's the bridge team. We need to find developers who are interested in learning security to become our subject matter experts, to become our security champions. Those security champions on the development team are going to be making sure, providing governance for the developers, make sure that developers are following security standards. Same thing for QA. The QA security champion needs to make sure that the QA team not only tests the product functionally, but also includes security testing into that. The same thing for DevOps, right? DevOps engineer needs to make sure that the DevOps pipeline accounts for all the security steps, security gates, the scanning that needs to be performed. Okay? What you ideally want to achieve is these champions growing in their security specialization and becoming what's called an evangelist, security evangelist within your organization. That evangelist is going to be responsible for recruiting more developers become security champions. QA evangelists will be recruiting QAs to become security champions, and so forth. And that will now start creating the engine that will grow your security specialization. All of a sudden, this bridge team starts growing, and that will position you well when you start forming your teams. Because there are 3 ways you can form your teams, I mean, at a high level. So let's say you're on team 1, put on a project. You need a security specialist. One option is to point a finger at someone and say, you're wearing a security hat now, go learn security. So you're going to be our security SME on this team, on this project for this client, for instance, right, if you're working for a vendor. Well, it's cheap to do that, obviously. The problems are obvious. The person may not have interest in security. The person may not know anything about security. So it's a steep learning curve. So this doesn't scale. Right? Another approach to this is to create what's called a center of excellence. Right? We have a centralized team that's responsible for security governance on all of our projects, for instance, right? But there are also problems here. These people aren't plugged into projects. They have their own priorities now. They're a separate layer, they're a separate team. They're not involved in any of the day-to-day happenings of the team. They're not aware of the client priorities. And really, it creates another layer of bureaucracy. Right? Now they have their own rules. Now you have to play by their rules, but you know, with Agile, that doesn't quite work out well, right? So the third one, the shared resources pool, is where we ideally want to end up. And that's why it's important to grow your champions and evangelists so they can help you create that shared resource pool. So you have shared resources being part of the team, but also working across teams so you can exchange the knowledge, train each other, increase that communication between the teams and knowledge sharing around the security. Okay? So this is ideally where you want to end up. So once you've formed the team, you need to start designing your DevSecOps pipe. First thing you want to do is obviously figure out what gates and steps you need to include in the DevSecOps pipe. And as we talked, you do that through the cost-benefit exercise. Once you figure out what types of security testing that you need to do as part of your DevOps pipeline, you want to lay them all out in a flowchart diagram. You want to lay out the steps in sequential order at first. You want to time them. Go through the entire pipeline. Build it out. Build it out before releasing it. Time and see how much each step takes. Write it out and then mark up the critical steps. Critical steps that have to be completed before the release can be marked as final, ready for production, right? Then mark up the ones that are parallel and try to move those up as close as possible to the beginning. Try to parallelize the ones that can be parallelized to reduce the potential of some of them overflowing. You'll actually be surprised how much delay you're going to have from the additional steps that you're going to include, from all the scanning. For instance, the dynamic website scan, 3 days. So what do we do now? Do we sit for 3 days waiting for that thing to come back with the results? Can't do that. So what we also have to be okay with is lowering the risk acceptance as part of this pipeline. This is another conversation that needs to happen. So we have to be flexible. We have to agree that we're not going to let certain flaws out, but we're going to say that we're going to be okay to let that security test run and finish because we're going to release in 40 minutes, but then in 3 days we're going to find out whether we had any problems. So there's going to be a little bit of trust involved there. Okay? And then mark up the optional steps. And then continue optimizing it, rerunning it, move the steps around, continue optimizing it to try to reduce the total amount of time it's going to take for the pipeline to complete. Okay? Just do be aware, these additional tests will add a lot of additional drag on the release pipeline. And if you're part of a large enterprise and organization, that's going to impact everyone who's involved with Sitecore. It's going to impact your testers. It's going to impact your business stakeholders who have to verify things. That's going to impact your developers, their time availability. Imagine someone having to stand by for all this time, right? So a lot of things are going to be impacted. So keep that in mind. And once you've optimized your pipe, change all the processes around this. Okay? Change the process for developer verification. Otherwise, if you don't do that, what's going to happen is you're going to have some kind of bug get kicked back from a unit test or a security test, and the developer's excuse, or like the functional kicked back by QA, and developer will say, well, the environment was unstable, I wasn't able to test it, or paste whatever excuse you want in that conversation because the system wasn't available. So you want to avoid those use cases, right? So you want to plan the process for developer verification, for content verification, for business validation around this pipeline. Okay? Infrastructure as code. So this is where we get into automation. DevSecOps really will fall apart without infrastructure as code. If you're not familiar with infrastructure as code, what that entails is creating scripts to create your environment. And you store those scripts in source code. Okay? And whenever you need to make a change to your environment, you don't log into the environment and make the change. That's the traditional way of doing things. You go to your scripts, and you make the change in the script, and you rerun that to update your environment. And you store those changes in the history of those changes in source control system, just like you do with code. So there are plenty of benefits here, but one of the most important one is cost savings. This is what really makes DevSecOps cheap with containers, because now we can cheaply automate environment setup, where with VMs it was incredibly impractical, inexpensive, and time-consuming. This is one of my favorite slides. So this is where we get into automation. This is what most people think DevSecOps is. But notice we spent half an hour talking about DevSecOps and then just now getting to the automation piece. This is where we can start thinking about what to include in our pipe, what types of tests to include. So we have a pyramid here on the right with the cheapest tests at the bottom, the most expensive tests towards the top. So you want to structure your pipeline in a way where you put the cheapest tests as close to the code commit as possible. Okay? So you want unit tests and static security check to happen as soon as the code is checked in. In fact, you could even create a gate, for a check-in to make sure that the code passes unit testing and security static scan before it can even be merged, for instance, right, for pull request. As you start moving up the pyramid, the amount of testing with each test narrows down because of the cost. Right? So the next level is SCA, which is a software composition analysis test, scans your dependencies. As Sitecore developers, we've been using NuGet packages for ages. And let's be honest here, who's ever checked any of the dependencies that you used from NuGet for security vulnerabilities? We got to talk. He knows what he's doing. You don't think about it, right? I mean, who's ever broke out a compiler and looked at inside Newton to see if our JSON deserializer just randomly sends our data somewhere else to a third-party service? Who's done that? But we don't know, right? So that's a scanner that can help us with that. Okay? So that can be automated. Integration testing, that's the integration testing as we know it. This is where we call Sitecore APIs and get the content back. Where unit testing, test specific units of operation. DTA container scanning. This is an interesting one. DTA scanning spins up a sandbox with our Sitecore instance, so we can spin up a container and observe the way our application behaves to see if there's any suspicious behavior, to see if there is a library that accidentally sends some requests out to a third-party service once in a while, or some suspicious traffic that comes out of the container. Moving up to the network scanning. So there are lots of options here for intrusion detection systems. Right? Traffic sniffing can identify suspicious behavior. My first job in the security space was at a university, sniffing dangerous traffic from college students. So I had to have awkward conversations about the websites they were visiting with them. I had to visit them and warn them that if this continues, unfortunately, would have to cut your internet access. Lots of fun stories there. Performance testing. This is an uncommon one, right? This comes from the availability. This is where we run stress testing This is where we run longevity testing. So if you're not familiar with stress test, is we test the point at which our application fails. Right? So we keep increasing the load until it breaks. That gives us an idea of how much we can handle. Longevity test helps us sleep at night. So we run it for at least, let's say, 3 days with elevated traffic to make sure that our application can survive a weekend. Right? And then load test is the traditional sense of load test. We put it under heavy load and observe how the application behaves. Integrated application security test. This is an interesting one. This is where security software observes the behavior of data at runtime. This is where a third-party tool, security tool, ensures that your password continues to remain secured all the way through its cycle. So let's say we got intake from a user for a login. So that is the application that's going to sniff out that password as it comes into the application at runtime. And it's going to make sure that it continues to be encrypted all the way through and it's saved in the encrypted format in the database. RASP, runtime application self-protection, checks if various data input changes the behavior of the application. And then dynamic security test, DAST, that's the final stage, which is a pretty relatively common type of security testing, does what's called fuzzing. So it tries to submit random strings of content into the application, trying to break it based on known security flaws. Okay? So as you can see, there's a lot that we can do, a lot that we can include in our pipeline. However, that doesn't mean that we now need to stop doing manual testing. So automated testing is great for coverage. There are certain economies of scale here, but there's also the law of diminishing returns, right? There's certain issues that are extremely expensive to automate. And those are the outliers that we have to check for manually. That's why we still have to perform manual penetration testing, bug bounties, and peer code reviews, and so forth. Okay? So to give you an idea, here's a pipeline we had to design recently, DevSecOps pipeline for one of the clients. They were using GitLab, for instance. They ended up with SonarQube for quality and static security scan. They did do unit testing. They did do the dynamic application security test and a load test with JMeter. Everything else was around the UI and the functionality. So there's a lot more, obviously, that you can add to this. But what you want to do, again, notice unit test is close to the CI, right? Quality check, security check. These are the cheapest tests that we can run. And they were put as close to the commit stage as possible. So with all that said, you can see that there are a lot of tools available to us. A lot of things that we can do in our DevSecOps pipeline. And it's relatively easy to integrate, especially with GitLab. GitLab has a lot of things now baked into it, right? If you go with GitLab, you even have the static test, the SAST as part of GitLab as well. Just this particular client chose to go with SonarQube. But you can do a lot of security testing just being in GitLab and without even having to integrate with external platforms, right? But unfortunately, the biggest problem still security is lack of specialized talent. Okay? So tools can't replace people just yet. Artificial intelligence is catching up. However, it's far out. So my hope is, today in this session, I sparked some interest around security. I hope you learn at least one thing today that you're going to take with you. You're going to apply it in your day-to-day job. And if you did take away one thing, promise me to talk to a couple of people at least about that one thing. So we can start educating the Sitecore community around security. Because in about a year, it's going to be exploding and growing. In fact, if you scan that QR code and send me your email address, I'll forward you some reports, and I'll forward you some additional resources that you can take with you to continue your journey with DevSecOps. So at this point, I'd like to thank you guys for joining. I'd like to thank our sponsors.
Hi, you've been talking about containers, Kubernetes, Docker versus traditional VMs. How do you feel about regular Azure PaaS instances?
How do I feel about PaaS?
Yeah, like in comparison to the traditional VMs that you were talking about.
Oh,
because, for example, if you use like ARM templates to deploy your instance as well, you you kind of do the same thing, but it's not in a container?
Oh, I think in the context of Sitecore, right? I think Sitecore or PaaS was not meant to run something like Sitecore to begin with. I think we squeezed Sitecore into PaaS. We forced PaaS to work for Sitecore in a way, right? It's also insecure. PaaS is also insecure. It's public, right? All the web apps are public by default. You can secure it, but it's expensive. And so if you're, I used to have the numbers off the top of my head. You can create the zones, but it's thousands of dollars that you're looking at, in terms of cost. So in the context of Sitecore, in the context of security, VMs are, I would say, more practical from a security perspective. You can do, if you know what you're doing, that's also a good, interesting point. If you know what you're doing, you have to know what you're doing. Because with VMs, it all comes down to knowing containers. Don't touch containers if you don't know containers. Don't release it in production if you don't know how to manage containers. If you don't know anything about security, you're going to shoot yourself in the foot. You have to know the technology, you have to know how to configure it, how to set that up. Only then you'll get the security benefit that I was talking about. I think with VMs, you have a lot more control over things. Also, if you're, depending on the rest of the infrastructure, VMs running things on-prem, still going to be more security. Even though you have all kinds of certs on AWS and Azure, right? Security certs. There's still a lot to say for companies having legacy applications. And you have to get tricky with tunneling data exchange between on-prem and cloud. Things can get complex. You can seriously lock things down if it's on-prem. So if anyone asks me from the security perspective, VMs. You have to educate. I mean, that's the most important thing, educating. Only then you're going to be able to create or understand or follow practices. If you don't get it, you're just not going to do it. You're not going to believe it.